Like when we round, like since it was over like 40 or 39. Yeah. So we round down always. Yeah.
So no. That's not rounding. That's your degrees of freedom. Your degrees of freedom is always n minus 1. So our n was 40. So that gets me to 39. And now was 39 on the chart. So now from here is what you're saying. Yes, I go to the highest thing below 39. Oh, yeah, that one was part B. I did want to talk about that. I wish the video. Well, so are you convinced that this type of engine has a mean nitrogen oxygen level of 1.0 or less? I'll make a note that this is in this video and not the other video. What do you think? Yes or no? Why? So the way, I mean, I'm just a visual person. And our interval said 1.1617, and we're saying it's between here and here, but it wants this or less. Is that right? So does our data show that it's going to be between here and here? No, our data misses that. So are you convinced that this type of engine has 1 or less? No. I can expand on this a little bit more. Y'all are good with me on that, right? So convince someone strongly using numbers why we don't think it's here. Based off of 95%. And this is a connection I haven't made yet. So I'm wanting you to see if you can make this connection. How unlikely is it? No. Is it exactly 2.5%? So because this is 95, that gives us all of this is 5%. So all of this, 2.5%, and all of this is 2.5%, which is farther to the left than that. So a piece of 2.5%. So there is less than a 2.5% chance that it actually could be here or less. Everybody with me at that point? So like now I would expect you to be able to answer a question like that. What happens if the number did fall in your interval? Then we wouldn't be surprised. But you can use numbers like this with the 2.5% to make your argument stronger. So based on ours, there's less than a 2.5% chance of that actually being the case. So we would definitely be surprised. And everybody's definitely good on that kind of answer.
And for the first problem, number 5, what was the T value that you got again?
Oh, you don't have a T for that one.
You don't, okay.
Because you need an N to find a T. So anytime you're finding sample size, you have to use Z.
Okay.
All right. I'm going to go through some generic stuff first. 3 different types of problems. Just take a second and look through them. And we're going to differentiate the different types of problems, so like how you know which type of problem it is on the quiz. And I'm using the same context and same general numbers for all of them on purpose. So they're all talking about spring high students. It's all talking about mean GPA. All of them are talking about 95% confidence interval. And all of them have standard deviation of 1.0 in there. So I've got this in all of them. I'm not going to do everything that says average GPA or spring high students. Those are all the same. Which one stands out as the obvious one that's different? What is the most obvious about why this one is different? And it does not ask you to do what? It doesn't ask you to actually make the interval. So that one should stand out on the quiz of what type of problem it is. It's going to ask you something like how many, how large, something like that. And this one gives us a standard deviation. This is not necessarily the only word this could be, but this is going to be a big helpful word when you're doing this, because that's going to end up telling you your what. This would be your what? Your margin of error. So you want to be within that, or it'll say something like plus minus. What's the difference between A and B? And it is very subtle. All right, so let's look just at where it says versus this. So this one, it tells you the standard deviation of spring high students is this. Well, spring high students is going to be our what? Population. So this is sigma. Whereas with this one, and sometimes I kind of think about it this way, we know this is our what? This is our X bar because it's of these students. So of these students, which is still from our sample, that makes this one. And that's the only difference that's going to be in a problem like that, to tell you that we're doing one with T and S versus Z and sigma. Y'all have any questions on that? So like a lot of the problems that look like B will literally say use sigma equals this, and that's fine. And that's very obvious, but it can be just in words like that. Oh, I guess like A, to where it just gives it to you and you understand that that's the population versus that's the sample. So I just wanted to make sure that we're clear on seeing the differences. I don't have this printed out. I guess if you want to take a picture of it, like if you need to look back at it, but if you feel good now that you've looked at it, then we're good with that. So just making sure we're all on the same page as far as determining what type of problem it is. The next thing we're going to do, I need you to have a calculator. So if you need one of mine, grab one. If not, get yours out. All right, so I'm giving you a problem where I'm giving you data. We're going to construct a confidence interval for it. We're not really going to do it, but we're going to theoretically, like we are. And we don't know what the problem gives us. So I want to kind of talk through what we can get out of that. So where do I want you to put those? In a list? And then once I have a list, what do I do with it? What do I do with my calculator? Once they're all in there, what do I do? If I want to find out stuff about it. one variable stats. So, and this is really important, what can I get from one variable stats for this group when I'm looking at it? This group on the board is considered a what? A sample. So, looking at that list directly, or the one variable stats right in front of you, what are things that are helpful right there? Sample main. What else? Which standard deviation? Because we haven't made a big point about this. So that is your sample, so you get S if you're taking your standard deviation from your list. Now, I could give you a problem like this and still say the standard deviation of all of the students was this. At that point, you would use sigma. So like that kind of overrides. But if we don't have a standard deviation to use, then we need the standard deviation from the sample. So we would take S, not sigma. And so that's the big part I need you to make sure you understand. And there's one other thing that's technically in there, but we already knew. Start, or what? N was 6. So X bar was 81.1667, I think. S was 15 point what? 75. And then, and there's a chance, we don't know because I don't have the problem, that I could find something else from this list, which would be what? Or need something else from using this list, and I would do what? It's not in do. What's something I might need to do with this list is not in do? Actually make the graph, so let's just, while we're here. Now, there's only 6 in there, so it's not going to be super helpful. But that graph, does that graph make us say, yikes, we absolutely cannot use normal? No. It's more uniform than anything else, but it is not really strong skew, and it does not have extreme outliers, so we're okay. And I'm going to come back to this later because I want to have it to where I can have things written down, but this is, the fact that it works if it's not perfect means it is robust to normality. So we're not checking to see if it's perfect. We're checking to see if it is horrendous. If it is not horrendous, it's still helpful to use, which means it is robust to normality. Like I said, I'm going to come back to that with something to write. But eventually we'll talk about the robustness of T. Any questions with this type problem? All right, so we're going to practice one to make sure we're all on the same page. If you'll put everything up except both sheets and a sheet of paper. Now, I'm doing it timed. If you have your stuff out and you just put it underneath, or you're like in a notebook and you're just not turning the pages, I'm okay with that. What are you trying to do? Okay, go to second flat line. Second, and then like up. Yeah. And you don't have your graph for that one, and that should fix it, but if not, that's fine. And in 10 minutes, I want you to do, or for 10 minutes, done in 10 minutes, I want you to do number 1.